Good morning, students. Today's topic is searching. Okay, under searching, what we are going to do, we are going to search for a particular element. Okay, if I want to enter the search element, I am going to perform searching. Okay, there are two major categories. One is linear search and another one is binary search. Okay, we are going to hold the data in arrays and we are going to simply search sequentially, that is linear manner. I'm going to check first value whether it is equal to search element. No, then I'm going to move to next value. Whether the value is equal to search element. No, then I'm going to search the third value. If it is equal to third value, then the value is my search element. Okay, so we are going to perform locating and retrieval of data is performing in linear search. The next topic is binary search. Okay, we are going to divide the data into two and we are going to perform search. Okay, the item that is searched is called as target. Linear search. Okay, we are going to perform linear search of data in an array from one end to another end. That is my lower numbered element of an array to an higher numbered element of an array. Okay, I am going to search and target value in my data set. Note the algorithm requires both tests are performed and that search terminate when one of the conditions become true. Here my second test is required to prevent the algorithm from attempting to search past the end of the data. Here an example. Here an array contains 14, 23, 7, 2, 19 and 9. So my array element is 0 is 14, 1 is 23, 2 is 7, 3 is 2, 4 is 19, 5 is 9. So I want to search an element survey. So it is in the third position. Okay, we are going to start with the first element. Okay, it does not match the target value. My target value is 7. So it's going to move. Next element I am going to search. It's going to search is 7 equal to 23? No, it is not equal. So I am going to move my pointer to next value. Whether my 7 is equal to 7? Yeah, my 7 is equal to 7. So I finally successfully find the value using my linear search. Okay. So, under these circumstances, what we are going to do, the linear search, we are going to search sequentially and I am going to retrieve those values. Okay, the array size is 10, I am going to search from 1 to 9. Okay, here my algorithm for implementing linear search, bool, it's going to return boolean is the new data type we are introducing in this class. Okay, what is bool? We are going to use whether it is true or false, boolean value, true or false. Okay, I am going to search linear search and integer pointers list, integer size, in key and breadcode. And I am going to, if it is found, I am going to replace false. Okay, integer I am going to check till the end of my array. So I equal to 0, I less than size, I plus plus. If the key value equal to list of I am going to break. Okay, if it is I value is less than size, I am going to found. Yeah, I found the values no. And I am going to use the address value I am going to record and I am going to return those values. Okay, it's going to looping from 0 to 1 n and I am going to search from 1 to till end I am going to search. So what is linear search? It is very simple. Linear search is sequential search. I am going to search from top to bottom, that is 0 to 10. Okay. That's all. It is very easy. Next we are going to move to binary search. Okay, I am going to divide the data into two. It is very fast search than linear search and also very effective search. Okay, we are going to regularly resorting and we are going to find. Okay, so we are going to give three labels index variable, that is called as, first one is top, middle and bottom. Top is the initialized one end of an array, that is often 0. We are going to initialize the 0 as a top and bottom is the other end of an array. So 0 is the bottom in the sense 10th is my bottom, top, bottom. Okay, middle is the value. Okay, we are going to compute. Okay, once these two values set, I am going to find this middle value. How I am going to find? Okay, that will be, I will tell you later. The value indexed by middle is compared with the target value. So I am going to compare randomly. I am going to choose a target value and I am going to find. Okay, so there are three possible things. One is the value is index middle as when we are comparing with the target value. In case the search has found the target, the function can return a value indicating the search has succeeded. The value is higher than the middle value, in which case only the values from middle to end need to be searched. The value is lower than middle value, we are going to catch array out from 0 to middle. Okay, if it is lower, 0 to middle. If it is higher, we are going to middle to end. If the value is in middle, we are going to search from the target. Clear? Okay, here is the boolean value. So I am going to initialize already as false, and I already explained the till the size -1 value I am going to consider as high. Low value is equal to 0 when the high value is greater than or equal to low, and I am going to complete middle. How I am going to compute middle? The lower value plus my bottom value, that is my higher value, divided by 2, I get a value. If it is key is less than that values, I am going to find the highest mid -1. If it is greater than that value, I am going to initialize the low value is middle plus 1. Else we are going to find that we are going to store that recorded value. Otherwise return that found. Okay, this is my very important illustration. So my value is 0 to 9. I am going to find the middle value, right? So I am going to divide 0 plus 9 by 2. Now my value is 4. Okay, this is my array. 0, 1, 2, 3, 4, 5 till 9. So this is my bottom. This is my top. Middle value is my fourth element, right? Here the C. Find the fourth element. So I am going to write middle value. Okay, I am going to find the value was target value was 29. So I am going to find this between this it's going to be a value because it is between bottom and middle. We already see three options, no? It is bottom and middle. So the value is higher than the middle value. When the value is higher than the middle value, what is my middle value? 42. 29 is less than the middle value, right? So it will be between bottom and middle. So I am going to again change the value. That is the middle value is top, bottom is bottom. So again I am going to compute, that is 4 plus 0 by 2, that is 2. So here my 2 value is middle. Now my value is 29. Yeah, it is very easy. Okay, there are some practical issues also there. Okay, if the top equal to middle, then the search can be concluded until the value of middle is the target. Then the search has determined the target is not in the data set. Okay, so we are unable to find in that particular key point. Okay, what is the advantages of using linear search? It is very simple because it is we are going to search in a order, so it is very simple. But a complexity, time complexity, we take more time. Okay, then binary search, and also it is more efficient in complexity because it is compared with the linear search. It is very efficient, and also simplicity, that is lagging in simplicity. So that simplicity is the advantage, but efficiency is the disadvantage. Here efficiency is the advantage and simplicity is the disadvantage. Okay, clear with the linear and binary search? Yeah, thank you students.